Welcome to integrals of product of sine and cosine. So I misspoke at the end of the last video. We are actually going to hit this before we look at powers of secant and tangent. So in this one, we're going to look at three specific types of integrals that all have essentially the same approach to solve. So the goal here is to integrate three different things. We have the integral of sine of ax times sine of bx dx. We will also take a look at the integral of sine of ax times cosine of bx dx. And finally, we will look at integrals of the form cosine of ax times cosine of bx dx. So it turns out that all of these can be solved very quickly using some very useful trig identities. So first up, we have that sine of ax times sine of bx is precisely the same thing as 1/2 times in brackets cosine of a minus b times x, and then minus cosine of a plus b times x. Similarly, we have the sine of ax times cosine of bx is equal to 1/2 times in brackets sine of a minus b times x plus sine of a plus b times x. And finally, we have that cosine of ax times cosine of bx is equal to 1/2 times cosine of a minus b times x plus cosine of a plus b times x. So note, all three of these formulas are very similar. The only difference between the sine times sine and cosine times cosine is that it's a minus versus a plus. And then the sine times cosine, we use sines instead of cosines. Also note that each of these formulas completely eliminates the products. So note, each of these formulas or identities allows us to eliminate the product. Which is very useful when it comes to integration. So let's just go ahead and do a quick example. Let's evaluate the indefinite integral, which is the integral of sine of 5x times cosine of 3x. So this is our mixed case. We will use the fact that sine of ax times cosine of bx is equal to 1/2 times in brackets sine of a minus b x plus sine of a plus b x. In this case, we will be using the fact a will be our 5 since we had a sine of 5x, and b will be 3 since we had a cosine of 3x. So what we wind up getting then is we have that the integral of sine of 5x cosine of 3x dx is equal to the integral of, we'll have a 1/2, then brackets, sine of, we do a minus b, so 5 minus 3x, and then plus sine of, we do a plus b, so we will have 5 plus 3x, and the brackets, and then dx. So this becomes 1/2 times the integral of, we have sine of 2x plus sine of 8x dx, and I need to give myself a little more space. So from here, our integral of sine of 2x and integral of sine of 8x are relatively simple integrals. We have our 1/2 out front. Sine of 2x, sine goes to a negative cosine. And then of course, when we have a 2x inside, to counteract that chain rule, we have to divide by 2. So we'll have a negative 1/2 cosine of 2x. Then sine of 8x, again, we'll have a negative cosine of 8x. To counteract that times 8x, undo the chain rule, we'll have to divide by 8 as well. So we wind up with 1/2 times inside brackets, negative 1/2 cosine of 2x minus 1/8 cosine of 8x. Technically, you can use u sub. So on the sine of 2x, we could do u sub with u equal to 2x. On sine of 8x, we could have done u sub with u equal to 8x. But as you get more comfortable with these, when you have that linear inside function, particularly if it's just a coefficient times x, you can skip writing out the u sub. All right, so we have this, and we have our plus c on the end. So this is how we go about evaluating the integral of that product of sine and cosine. Just simplifying a little, we wind up with negative 1/4 cosine of 2x minus 1/16 cosine of 8x plus c. Now let's go ahead and do another example. This time around, we're going to evaluate the definite integral. We have a cosine times cosine situation here. So we are going to use the fact that cosine of ax times cosine of bx was equal to 1/2 times, in brackets, cosine of a minus b x, and then plus cosine of a plus b times x. In this case, our a is 2, our b is 3. It doesn't matter which one you pick as your a and b. You could also pick your a to be 3 and your b to be the 2. So we are looking at the integral from 0 to pi over 6 of cosine of 2x, cosine of 3x dx. This should be equal to the integral from 0 to pi over 6 of 1/2 times, in brackets, cosine of a minus b is 2 minus 3 times x, plus cosine of a plus b, so 2 plus 3 times x, and then dx. So this is 1/2 the integral from 0 to pi over 6 of cosine of negative x plus cosine of 5x dx. Note, cosine is an even function. Cosine of negative x is just the same thing as cosine of positive x. So we could rewrite this as 1/2 times the integral from 0 to pi over 6 of cosine of x plus cosine of 5x dx. Integrating, we are looking at 1/2 times integral of cosine is just sine, so that cosine of x will just go to sine of x, plus cosine of 5x will get us positive sine of 5x. Counteract that chain rule, we will have a times 1/5 out front. And we are evaluating from 0 to pi over 6. So this becomes 1/2 times sine of pi over 6 plus 1/5. Oh, the 1/2 is multiplying this whole thing. So 1/2 in brackets, sine of pi over 6 plus 1/5 sine of 5 pi over 6 and brackets minus 1/2 times in parentheses sine of 0 plus 1/5 sine of 0. Those sine of zeros all go to 0. Sine of pi over 6 is 1/2. Sine of 5 pi over 6 is also 1/2. So we are just looking at 1/2 times in parentheses 1/2 plus 1/5 times 1/2, or 1/2 times 1/2 plus 1/10 is 6/10. And we wind up just getting 3/10 for our definite integral. So again, when we have products of sine and cosine, no powers involved, we can use our nice quick identities to reduce it to a very simple integration problem. Right, in the next video, we will now look at powers of secant and tangent inside integrals.